How do large language models actually work? ChatGPT, Claude, Gemini under the hood, all of them do one surprisingly simple thing. Over the next hour, we will build one from scratch, one piece at a time. Let's start. You have seen this before. You type a few words and the model continues them. Take the sentence, "The cat sat on the," and the model fills in the blank, "mat." It feels like magic, but it is not. The model is not looking up a stored answer, it is making a prediction. Given everything so far, what word most likely comes next? That single question, what comes next, is the entire job of a language model. Let's make that precise. The model reads the word "so far," "the cat sat on the," and produces a score for every possible next word. Not one answer, a whole ranked list. Here, mat gets 61%, floor 12%, rug 9%. Ground, sofa, and thousands of others share what is left. These scores are probabilities, numbers between 0 and 1 that together add up to 100%. The model's grip on language lives entirely in how it hands out these numbers. So how does a few words become a whole paragraph? By repeating. The model predicts one word, mat. Then it adds that word back into the sentence and predicts again, "The cat sat on the mat," and then again, purred. Each new word is fed back in as input for the next prediction. This loop, predict, append, repeat, is called autoregression. One word at a time, the model writes. That is how every reply you have seen was made. Let's look closer at that list of scores. The model does not choose from a few words. It has a fixed vocabulary, often 50,000 pieces of text or more. For every prediction, it scores all of them at once. Almost all get nearly 0, only a handful stand tall. Picture a bar chart with 50,000 bars and just a few reaching the top. Choosing the next word means drawing from this distribution. Soon we will see exactly how these bars are computed. But how does the model turn words into these numbers? Through a pipeline of stages, and this pipeline is the map for our entire course. First, tokenization, chop the text into pieces. Then embeddings, turn each piece into a list of numbers. Add position so order is known. Then attention, let each word look at the others. A feed-forward network to process. Stack that block many times. And finally, turn the result back into probabilities. Every chapter ahead is one box in this diagram. One more thing makes these models powerful: scale. Inside are numbers called parameters, the adjustable knobs of the model. Small models have millions of them, the largest have hundreds of billions. Each knob was tuned automatically by reading enormous amounts of text, trillions of words. Nobody wrote the grammar rules by hand. The model learned them by practicing next word prediction billions of times over. So let's be honest about what this is. Underneath, a language model is just arithmetic, additions and multiplications, on big grids of numbers called matrices. There is no little person inside, no shelf of memorized answers. Just one mathematical function: text goes in, probabilities come out. A very large function, with its knobs tuned to make good guesses. Everything that feels mysterious comes from scale, not from magic. That is the big picture. A language model predicts the next token again and again to generate text. Its knowledge lives in billions of tuned numbers. And it is all built from a pipeline we are about to explore, one stage at a time. Next up, tokenization, how text becomes numbers in the first place. Let's begin.